Hi, hi, good evening, everyone. Can you hear me? Thanks, yeah. Thank you all for joining us in today's webinar. My name is Deepika and I'm the community manager at Analytics Vidya. Analytics Vidya is the leading community of data scientists in India and across the globe. Small update for all of you. We are arranging an exciting event. Analytics Vidya is hosting India's most exciting conference called Data Hack Summit 2017 in Bengaluru from 9 to 11 November. The conference hosts Dr. Kirk D. Bone, Principal Data Scientist of Booz Allen Hamilton, as the keynote speaker. Make sure you check it out. Thanks for being here. So I'll introduce you to today's session. Today we are hosting a webinar on automated machine learning using MLBox Python package presented by Axel D. Romblay. Axel is the creator of MLBox Python package, which does most of the heavy lifting in machine learning in minimal lines of code. He's a data scientist at Group Credit Agricole, very passionate about deep learning and AutoML. He has done his master's in data science at École Polytechnique, one of the top French engineering schools. Thank you, Axel, for joining us. Let me get him on board. Hi, Axel.
Hi. Is it good for the sound?
Can't hear you.
Yeah, good and you. Okay, so just need to share my screen.
Hi, I can hear you now.
Yeah, it's okay. I can hear you.
Thanks, Axel, for joining us.
Yeah, thank you.
For the audience, if you have any questions during the session, please type them into the Q&A section. Before we begin with the session, I would like to have a small poll.
Okay.
Guys, please vote. We'll run the poll for a few more seconds and then I'll share the results. Let me end the poll. I'm sharing the results.
Okay.
Most of our attendees, they have less than 3 years of experience and
they have never used MLBox, but they understand Python, so it's great.
Yeah. And
nice.
Very few of them know about, they've used MLBox, so this was the best webinar. I think they'll want to learn about your library. So, Axel,
yeah, I can see it.
Okay.
Yes, yeah. Maybe I can start sharing my screen.
Yeah, you can do that.
Okay. Okay, so yeah, that's it. Is it okay now? Yeah. Do you see the screen?
I can see the screen.
Like this. Is it okay for you? For everybody?
No, you can't see the entire slide.
New share. Okay, no problem. Here. Is it okay now if I share my screen?
Are you opening the presentation?
Yeah. It is opened? Yeah. Just to stop share. I will try a new share.
Sure.
Share screen. So yeah, share screen. Yeah, but I can select only a window with MLBox. That's it. No. No.
No.
It's written. I've shared my screen right now. So.
No, I can't.
You share. Select a window, an application you want to share. So I would like to share my desktop. Share screen. It's not working.
This is not the presentation deck, I guess. It's.
What can you see actually? No, you don't see the.
Yeah, I can see. Yes, we can see now.
Is it okay for everybody?
Yes, I think it's
okay.
Okay.
If I like this, if I change. Okay.
Yeah, it works.
Okay, so maybe I can start. The webinar. Yeah.
Yeah.
Okay. Well, so today is the special webinar on automated machine learning, as you all know, and especially I'm going to talk about my brand new Python package, which is called MLBox. So you had already introduced myself, so I'm going to skip this slide. I just first, before we move on to the technical points, I would like to thank Analytics Vidya for hosting this webinar, and I also would like to thank all the people that are participating to this webinar. I hope it's going to be useful for you. So let's start first with a small introduction on AutoML. So AutoML is automated machine learning. And we are going to focus about why AutoML, what is the key points in AutoML. So as you all know, machine learning is a kind of semi-manual process. That is to say, you got a lot of automatic algorithm, but not everything is automated. Indeed, if you have a close look at what you have on the left side your data, okay, and on the right side you have your computation and means. That could be a CPU, GPU, or your RAM. And the data scientist is between those two entities, and is asked first to do data preprocessing. That is to say, you have raw data, and he has to preprocess the raw data, and also he has to optimize or fine-tune his model, his predictive model. And these tasks can take a lot of time, and can be very expensive for a company that is hiring a data scientist. So this is a classical machine learning task, and the idea is to go fully automated process. That is to say, the idea you have is to replace the data scientist by a robot, a kind of automated robot. And the robot will do the pre-processing and the optimization for you. Let's see in detail what can be automated and what can't be automated. So what is easy to automate is a supervised problem. Let's say classification or regression. That is very easy to automate. And regarding the data, if you have structured data, like a CSV file or JSON file, this is very easy to pre-process automatically. But what is very tricky is unsupervised tasks like outlier detection or whatever. This could be very tricky to automate. And regarding the data, if you have non-structured data like images, text, graphs, or whatever, it would be very difficult to automate and to pre-process. So these points are tricky, and we're going to focus on the easiest parts. Okay, so now we have understood the necessity of automating classical machine learning with a robot, a kind of automated robot. But what is exactly AutoML? So I will start introducing what we call AutoML. So AutoML, actually, what do we want to automate? We want to automate the maximum number of steps in a standard machine learning pipeline. Okay, so we have seen it before. We want to automate the pre-processing. We want to automate the optimization steps. We want to automate the prediction steps and the maximum number of steps in a standard machine learning pipeline. Okay, this is the first point, and this is the most important point. Then we want to automate so the maximum number, but with minimum human intervention. We need a fully automated pipeline. That is to say, the user is prohibited to to change parameters or whatever. It has to be fully automated. And while conserving a good predictive performance, we want our robot to be as accurate as possible. And finally, with a low time computation. We don't want our robot to learn a lot of model during 1 or 2 weeks. We want something very accurate and fast. And these 4 points is what we call automated machine learning. That is the definition we can have of AutoML. Now, if you have a close look of the schema of the standard ML pipeline, this is the following. If you will notice that, like in 80% of machine learning pipeline, this is the following one. The first step is reading and merging your files. So the inputs are raw databases, several databases, and you will need to crunch your files and read them before, but crunch them to have one structured file. So this is the first step. Once you have your structured files, you will go through step 2, that is pre-processing your files. When we talk about pre-processing, we have 2 steps. The first one is what I call data cleaning. So data cleaning is like removing duplicates, IDs, and correlated features, and so on. And data encoding is the step where you encode your data. For instance, let's say your structure file has missing values. You will need to encode these missing values. Also, if you have like dates or text or categorical feature, you will need to encode all these features. once you have done this, you have you output one structured file, one numerical structured file, and then you can apply your model. Actually, this is step 3, what I call optimization step. So the idea behind this step is to optimize a lot of models, try and test a lot of models, try some feature selection. So you will need to find the good algorithm to select relevant feature. So this is one step here, feature selection, okay? And also you can do what I call feature engineering. So you can create relevant features from the original data set. And then you will go through model selection. And here you are going to try and evaluate a lot of models, a lot of parameters, and so on. You will go through this cycle until you have good parameters and a good performance. This is step 3, optimization. And then finally, you will go through step 4, that is application or prediction. You will predict, you will fit your best model. Okay, you have learned from step 3. You will predict on your test set and give a model interpretation. That is also very important, because you don't want like a black box model. You want also your model to be interpretable. That is all these steps is the standard machine learning pipeline we want to automate. But let's see in detail what can be automated and what can be automated. So here you will see that, so in green, this is easy to automate. It's very easy, you know, to predict and to fit a model and to predict on a test set. That is an easy task. To optimize is also very easy. To try and to learn a lot of models, that is easy to automate. And pre-processing will be a bit harder, since you will, for instance, you will choose the good parameters for encoding your missing values, but also you will need to detect if a feature is a text or an image. Also, you will need to delete IDs. That is not an easy task, and so on. So it's a bit harder. And the step 1 is the hardest steps to be automated. Actually, it's very difficult. It's easy to read, but it's very difficult to crunch your database into one file, because you can have duplicates in your files, and it's very difficult to know if it's a true duplicate or not a duplicate. So this is a bit harder. Now, if we have a close look at the human intervention, actually, every steps are easy to automate. Yeah, they doesn't require a human intervention, actually. Regarding the accuracy, this is not actually a problem also for all the steps. But if we have a close look at the time computation, of course, step 3 can be very greedy. So this is a problem also. Here is the recap of the criteria of automation. And if we sum up, we can say that step 4 is easy, step 3 is almost easy, yeah, and step 2 also, but step 1 is the hardest part of automation. Okay, so now let's move on to different solution. I've tried to recap. So if we have an overview of different solution in the data science, I've summed up this this table. So I don't know if you guys know Data Robot or AutoScikit-learn, but they are like a solution or a Python package in data science that are trying to automate this pipeline. There is also Teapot and of course MLBox, and we are going to compare the tool between each other. So the first criterion is the quality of automation. They are all good except for AutoML, which is not very good. It's not truly an AutoML package. So you can have a try on the GitHub and download this package. You will see it's not very automated. For instance, you will have to tell the robot which feature is a categorical feature, which feature is a date, which feature is a numerical feature. So it's not truly automated. Now, if you have a look at the steps that are automated, Teapot is a good one, but it's only automated optimization. Whereas MLBox, for instance, is automates the reading, the merging of the file, the cleaning, the encoding, and the optimization step, and of course the prediction. So it's almost a fully automated package. The maintenance, this is also very important. Autoscikit-learn is very old, so it's not actually maintained at the moment, and otherwise the other is good. The ease of setup is also very important, because even though you have a package that is full automated, that works fine, you will need a setup that is easy. You don't want, your package to have errors or whatever while setting it up. So it's very important. And MLBox is, you can see like a package on the top of other machine learning package like scikit-learn or other Python package, and all the dependencies are automatically installed. So this is very important. And they are all open source except DataRobot, that is not free. It is a solution that is not free. Okay, so now let's move on to MLBox. We are going in this part to focus on the features. Okay, so as I told you before, MLBox is a fully automated pipeline, and I'm going to show you. So for the step 1, that is reading and merging, we want from several raw dataset, we want one structured dataset, and you only have to input the list of passes to all your datasets and the target name, and MLBox will do the job for you. It will read all your files, CSV, JSON, and other format. It will do auto-merging of all your sources, information crunching, and it will automatically detect your task. That is to say, it will detect if it's a regression problem or a classification problem. And then it will split your dataset between train and test. And also display some basic information, like on the target or sparse feature and so on. And then it will output a dense structure train and test file without duplicates. That is step 1, that is full automated. Step 2, we want a clean numerical dataset. It will do auto-cleaning and dropping of duplicates, drifts. I will talk about this later. So it's like unstable features. It will drop these features. It will drop correlation, sparse features, constant features, and other. And it will do other cleaning, and it will encode your features. So it will encode your missing values, list, dates. It will deal with categorical features and so on. And there are also several strategies for the encoding. Then, if we have a close look at the optimization, it will test a wide range of models and will output an accuracy score for each model. So what you have to input, but it is optional, you have to input a metric. And here you have a wide choice of metric. You have to input a space of hyperparameter and the train set. And then it will do feature engineering for you, feature selection, model selection, and also hyperparameter optimization using a Bayesian optimization method. So it's not only about a grid search or testing, you know, with randomness parameters. It is a clever or hyperparameter search. And also you can do ensembling or blending. You can do bagging or stacking. You can stack your models. This is also possible with MLBox. And this step will output the optimal pipeline configuration. And then you will need to predict on your test set. So the best model will be fitted and then will predict on the test set. As I told you before, step 3 will output the optimal pipeline configuration, and step 4 will output the prediction on the test set. It will also give you a model interpretation that is very important. So basically it is feature importances, and also it will automatically detect leak features. That could be also very interesting. Now, I would like to talk about the package itself. It's a Python package, of course, that is compatible with Python 2 and Python 3. Okay, so it will work on both versions, and also compatible with Linux OS. At the moment, it is not compatible, or you will need to install it on your own, but it's not automated for Windows and Mac, but it will be soon. It will be released like in 1 month or at least 2 months. And regarding the setup, it is very easy, as I told you. You just need to run the following command here, pip install MLBox, and it will automatically download the MLBox package from the PyP repository, and will install all the dependencies and will install the MLBox for you. So this is the only command you will need to run to install the MLBox. And then it has to be also user-friendly. So it's not only about a full automated package. It will need to be very easy to use, and I will show you this later. So you have a lot of tutorials, a lot of documentations, and a lot of examples. So it is very easy to use. Now, regarding the quality, actually the package is functional. It has been tested on Kaggle. I think you know Kaggle, so it's the world's best data science platform, where you have data science competition. So it's a good opportunity for me to test MLBox on this website. And for instance, I've tried to run MLBox package on a Kaggle competition, and I ranked 85 out of 2,500, I think, something like this. So it's a good accuracy. Also, it also needs to be fully distributed and optimized, and also it has to be, you know, clever robot. So it will try a lot of models, but it will automatically read computation that has been learned. If, for instance, if you fit one model and another day you will refit this model, it will be clever. It will just read your computation from the disk. That is very important to have a low time computation. Also, it has the latest algorithm in the data science market, for instance, JBoost or LightJBM. So they are all integrated to MLBox. Here is the link to the GitHub. So you can have a look to this GitHub, where you can find the tutorial, the documentation, and a lot of things, how to get started with this package. But I will show you this after. Let's move on now to the first algorithm I've coded, and that is inside the MLBox. So MLBox is not only you know, a Python package on the top of scikit-learn or other famous library. Also, it has some brand new algorithm inside I've coded. So the first one is what I call the drift algorithm. Okay, what is drift detection? Okay, this is the issue. So you have here your training data set, okay, and your model that will fit your training data set, okay, and will learn your parameters. And then you will need to predict and score your test data set. But when you do this, you're making a strong hypothesis. You suppose that your data are independent and identically distributed. That can be wrong in practice. And this is almost the case in data science. And in practice, data are biased and there exists what I call a drift. Let's see, for example, if you have the feature in your training data set, the feature age, and you learn a model on young people, okay, and then you are told to predict on older people. And that can be a problem, of course, because the model has only seen and fit on young people, and then it is asked to predict on older people. And that leads to a score that is lower, generally speaking. So this is a problem. This is the issue of the drift. And the purpose of this algorithm is to control the model's performance. So how can we handle this issue? This is a quick reminder or quick definition of the famous formula. If X is your features and Y your target, you have the following relationship. So here is your training data set, okay? So you have one feature here and a second feature here. And here is a binary classification. So red is one class and green is one class, okay? And here is your model. So if this change, so the target given the feature, if this change, it is what I call concept shift. So this is the same features, but the target has changed, okay? And now this is this term that changed. It is coverage shift. So the labels are the same, you know, the model is the same here, but features have moved. And we are going to deal this case. Okay, so the solution is the first step is we want a drift estimation for each feature. That is to say, we want to have a coefficient, a drift coefficient that characterize our feature. And the second step is now feature selection in order to maintain the model's performance and to lower the drift, the risk. How we do that? With the following algorithm. So for step one, that is drift estimation, this is the algorithm. So we're going to label our data, whether it belongs to the training or the test set, and then we're going to fit a classifier to separate both classes, and the scoring, the ROC IOC scoring, will give us a drift measure for each feature. And we will be able to rank our features in a decreasing risk order. And then this is the feature selection part, where we want to remove drifting features, and we want our model to be not degraded. So that is the greedy recursive drift elimination I've coded. So yeah, so the idea behind this algorithm is to try to drop a feature, and if the score is lower than a threshold, we'll keep these features, otherwise we will drop it. That's the idea behind this algorithm. Okay. So let's sum up the best cases scenarios. So the best scenarios are, first you have a 100% drifting features. So of course you are going to drop this feature since it is risky. 0% drifting feature, well, you are going to keep it. Okay, so it's very stable between your train set and your test set. And drifting features that are not important, useful for the model, we're going to drop it. Okay, so this is easy to deal with. The worst case scenario, it is when you have an important drifting features. And this is very tricky to deal with. And there are two subcases. Okay, so let's deal with the first one. So here is the curve for the drift measure per features. So you will see that all the features are drifting. They are all risky. And this is the score, the delta score for one feature when you drop it. And here you see that if you drop the first feature, you will be very close to the maximum threshold for delta score. Otherwise, let's say in other words, you will drop only these features and you will keep all this feature, so you will keep all this drift. And the other subcase is that you have only one drifting features, but you go beyond the maximum threshold for delta score, and you are not going to remove this drifting feature. Okay, so now let's move on to a second algorithm that is inside the MLBox. So we are going to focus on another new algorithm that is inside MLBox Python package. So the second one is what I call entity embedding. What is entity embedding? So as I told you before, a classical machine learning algorithm will need numerical features. So you will have to input in a classifier or a regressor, you will have to input a numerical matrix or data set. And what if you have categorical features? You will need to encode these features. And how do you encode categorical features? So there are several methods you can do. The first one is what is called label encoding. So it's a naive encoding. Here is the explanation. So how it works. For each categorical feature, you will encode each value using the lexicographic order. For instance, A will give 1, B will give 2, and so on. This is how you are going to encode your levels of your categorical features. This has some advantages, of course, because it is very quick and scalable, but the drawbacks are this is very naive encoding and not understandable. Then what is called dummification or binarization. You will binarize all your categorical features. For instance, it will give features 1 A, feature 1 B for level B, and so on. So this is less and less naive encoding, but it is not scalable. If you have a lot of levels, this will lead to a highly dimensional matrix. So this is a problem. You also have random projection, okay? So random projection is a kind of label encoding, but in k dimension. So it's almost the same. You can also discretize, gather your value, okay? And finally, you have the entity embedding method. How to do, we will see it next. And this is accurate, scalable, understandable, and quick. Okay, so now let's go through the idea behind the entity embedding. So the idea behind the entity embedding is that we would like to learn a smart or a good vectorial representation in an Euclidean space. Okay, for instance, if we have a look to the label encoding or random projection, you will introduce a distance between two values that is random. For dummification, you will introduce a distance between two values that is constant. And for entity embedding, you need to introduce a distance between two similar values that is low and vice versa. And how we do this? We will use a neural network to learn this representation of your levels for the categorical feature. Okay, let's go deeper. Okay, here is the neural network for entity embedding. Okay, so feature 1 to feature P is your categorical features, and here the neurons are the levels. Okay, so you have one hidden layer, another hidden layer, and the last hidden layer is here, and the output. So the encoding is the following. You need to get the weights between the one encoding layer, so this layer, and the embedded layer. So if you get this weight, you will learn the representation of your levels. Then you will need to choose the number of units for the embedded layer. That is not an easy task because you can choose it constant, equal to 2 or 3, or proportional to the number of values, and you can choose whatever you want, so it's tricky. You will need also to choose the number of units in layer 1, and also you will need to choose the number of units, the number of layers and the dropout and so on. So you have a lot of parameters to try. Maybe that's the drawback of the method, and the output is your target. So, and then if you fit this neural network on your categorical features and you get the weights here, okay, you will learn the representation. Let's see this on a real data set. So I've tried this method, okay, on a real competition data set. So the data are available here on this website, okay. So it's a data science challenge like on Kaggle, and we are asked to predict the price of an automobile insurance policy, and we have a training set, okay, and features like the brand of the car, the age, the postcode, and the energy consumption, and so on. Okay, we have like 43 features. Here is the head of the data set, okay, of our data frame. So it's written in French, sorry for this, but here is the brand, okay, and these are the levels, but you have more than 100 brands. So this is a problem. And you have also energy consumption and sea levels. You have like essence, diesel, and so on, electric cars, and so on. And here is the target. You will need to predict a price, okay, for your insurance policy. Okay, so now let's have a look at accuracy and quickness of the entity embeddings. If I run my MLBox with a label encoding, a naive label encoding, I will get this mean absolute error. So this is the mean absolute error I have. And if I run now my model with entity embedding as the encoding method, okay, here is the categorical encoder. So I choose entity embedding as a strategy, and you will see that I will be more accurate. Okay. Now, if I look to the quickness, of course, label encoding is faster. But as I told you before, MLBox will do this computation once, and then it will read from the disk. So it just, you know, you will have to learn this only one time, once. So it's not a problem. Now let's see the scalability and the understanding of this method. So it's very quick, okay, to learn all the data sets. And here is the weight you will get for the brand, okay. Here is the brand, the encoding of the brand, okay. Here is the encoding for the energy consumption. So you have weights, and when you see this, maybe you can say it's not understandable, but actually it's not. So it is scalable, but it is also understandable. Here is the projection, okay, of the cars in a two-dimensional space using the weights, okay, this encoding. And if you see, if you can see the data points, here is ranked with energy consumption. So here is one color, it is one energy consumption. Here is another energy consumption. Here is another energy consumption, and so on. So it is ranked. And here, so the cars are ranked using the ranking of the the increasing prices. Okay. So it makes sense actually. So you have an encoding that makes sense. Okay, well, that's all for the focus actually. So this was just to show you that MLBox is not only about, you know, classical algorithm. Inside, you can use neural networks to learn an encoding of your categorical feature. You can have a drift measure of your feature. That is a brand new algorithm in data science. And there are also a lot of tricks like this inside. So now let's go through a kind of demo of the package. So let's have a look at I don't know if it's okay for so here is a famous data set on Kaggle. So here's the website, the famous website, okay? And the competition is you will need to predict, you have to predict whether people are going to survive to the Titanic or not. Or here is the data set and description, okay? So you have a training set and a test set, okay? You will learn your models, all your models on the training set, and you will also test your model on the test set. And this is the data dictionary with all your features. So this is the target we want to predict, okay? Survival, no, 0 and 1, yes, okay? And you also have the ticket class, the sex of the passenger, the age, and so on, okay? And given these features here, you will need to predict this. And so I've run AutoML Python package on this data set. So, first, it will require it to be installed on Kaggle. So that is the case. Now you can run MLBox on Kaggle kernel for those who know. And let's see what it outputs. So this is all you will need to give. So MLBox is a Python package, so you will need to import the set package, pre-processing here, okay, optimization and prediction. Then once you have imported MLBox Python package, you will need to give the paths to your data, okay, to your train set and your test set and all the data sets you have. So here it's easy, it's only train and test, but you can have several training files and several test files and so on. And the target name, here it survives, also, yeah, survives. And now let MLBox do the job for you to learn a lot of models, encoding of your feature and so on. So first you will need to read and clean all the file you have. So here you need only to code 2 lines, to write 2 lines of codes. So the first one is to read. Yeah. So you will only need to run this and this. And this is the log it outputs. So it's reading the first file, it is cleaning it, that puts the time, so it's very fast. Test, cleaning the test file, very fast. And now it will display some basic information. So like the common set of features, okay? It will drop constant features, duplicates, output the categorical features, number of numerical features, the size of your training sets, the size of your test sets, okay? And the top sparse features will have. So cabin is the sparse feature. So there are a lot of missing values on the train set for this feature. Age also for age and so on. Okay, so this is just the top 3. And it has automatically understand that is a classification problem with the following repartition of your levels. So there are like 500 people that died on Titanic and like 300 that survived. Okay, and also it is encoding your target because if you have a look at your data, it sees 0 for no and yes. Yeah, yes, 1 is 1. Something like this. Okay, so this is only about reading your files. Okay, now you will need to remove your non-stable feature, your drifting features, like I told you before, I introduced it before. So here, also 2 lines of codes to remove the drifting features. And here you will see it makes sense. It is easier to understand what is a drifting feature. So in your dataset, you have a feature that is called passenger ID. So it's an ID. And of course, the passenger ID is different between the train set and the test set. So it is a drifting feature, and it is very risky to fit a model on while keeping this feature. So you will need to remove this feature. Name also, the name of the passenger is a drifting feature. And the ticket is also drifting. Otherwise, other features are they are very stable. Okay, so you are going to automatically remove these three features, and the coefficient here, drift coefficients, are saved into the directory. Let's see here, output. Okay, you have the drift coefficient for all your features. Okay, so 0, it is a very stable features, and 1 is the most drifting feature. Okay. No, let's go to the version of this. Sorry. Okay. Okay, so we were here. So here is the end for the pre-processing and the reading steps. So the first 2 steps. At the end of this, you will get a dictionary with your training set, your test set, and your target on the training set. Now you will need to tune all your hyperparameters. So first you will need to give the scoring function. Here is it just accuracy, and you will need to give, but it's optional, the number of folds for the cross-validation. Okay. And here we are going to test a famous boosting algorithm that is LightGBM. So you will have to define your space into which you are going to optimize your model. So here I can choose the strategy for my final estimator. So I will try LightGBM, but you can have a look at the documentation. You can try XGBoost, a linear model, a tree, a random forest, or whatever. You can also precise the number of estimator and all these parameters. Okay, and then we are going to optimize in this space. So the algorithm will try different pipeline configuration. Here it's so it's a default configuration for this encoding and this encoding, but it will try different estimator configuration. Here is the log, so it's very kind of complicated. You have your accuracy score for this configuration with the variance and the time. Then it's testing another hyperparameter configuration. Yeah, okay, and so on. So testing a wide range of parameters. Okay, and then it will output the best hyperparameters for your model. But of course, you can tune the whole pipeline. Here, we have decided just to tune the estimator, but you can choose different strategies to impute missing values. You can choose different strategies to encode categorical features. And you can also try some feature selection and also tune the parameter of the feature selection. You can add stacking meta features, and you can, like here, you can tune your models. So here, it's very important because here's the example is only to tune about tuning the estimator, okay? But you can tune actually your encoding, the strategy of encoding missing values, and so on. So you actually can try all the strategies for each step. For example, you can try entity embedding as the categorical encoding. You can try a random forest feature selection, right? And then you can try a linear model, and it will output the accuracy, mean accuracy on the fault, across the fault. And it will give you the best hyperparameter space parameter. Yeah. And then once you've got that, your parameters, your best parameter, you can predict on your test set that is in memory. And it will output the top 10 feature importance and also the feature importances into the directory save, and will predict and will give you an overview on your prediction. And your prediction will be saved, automatically saved into directory save. That's all. Here, just formatting for the Kaggle competition, so you don't need to do this. If we have a look at output, you will see that this is the output of the MLBox. So it will give the probability for each class and the prediction. You will have the drift coefficient for each features, and you will also have, is very important here, your feature importance for all your features. So of course here it makes sense since the fare is very important. The age is a very important feature to decide whether a passenger has survived and so on. So it's very important to have this model interpretation. I think that's all for the presentation. It's almost 1 hour. So if you have a question, I can see here. Stop share, I guess. Okay, so now let's answer the question. So yeah, I'm gonna answer live. I think you can hear me. So now MLBox is not available in Anaconda because it relies on several packages like XGBoost and LightGBM that are not available in Anaconda. So I can't push MLBox in Anaconda distribution. If you want, yeah, tutorial links. Okay, sorry. Okay, tutorial links, they are available on the documentation. I can show you now. Share screen. Yeah, this is the desktop. Okay, here is the, okay, nice. Yes, here is another tutorial you can find on Kaggle, but here it's a regression problem, and the purpose is to predict the price of houses. So it's the same. You have your features. You will try several models, okay, and will output the price for each house. Okay, but also if it's too tricky for you, you have the GitHub. So the main page is here. Here is the page where you have the code. So the code is available here. If you have if you want to see what it looks like, for instance, encoding, here is the code to encode your categorical features. So you have a lot of strategies, of course, okay, and here is the code. But if it's too complicated, of course, you have, and that is very important, tuto. So where you can find tuto on the official documentation. And this is the official documentation for MLBox package. So there are a lot of links. So the Kaggle kernels I show you here, articles from users also, webinar links, and here is the installation guide, how it works, okay, and a nice tutorial on how to get started with MLBox. So the imports, here are the inputs, and then the code you have to run. If you have a doubt about a function, you have all the documentation here, all the function, the reading, okay, the drift thresholding, and so on, okay. The categorical encoder, so the parameters, the inputs, what it does, and so on. So this is all the documentation you will you have here with example and so on. So this is the documentation. Here's a nice tutorial, and also if you want a true tutorial, you can click on it on the Kaggle kernel and so on. Okay. Okay, stop share. So that's done. Okay, now whether it can be used on a Windows machine or not. So at the moment, it's not available on Windows because it is difficult to install XGBoost and LightGBM packages on Windows. But if you already have it on your computer, it will work. You can try pip install MLBox and it will work. But I'm working at that point at the moment, so it will soon be released for Windows and Mac. Okay, so the same question. Please share the GitHub link. So here is the GitHub, of course, editing GitHub. Here is server text. Where is sent? Okay. Will be available online as well. It would be great if you share. Oh, you made it. Okay. So for the documentation, it is tricky actually. So it has been made using Sphinx or Read the Docs. You can have a look. Read the Docs is the tool I've used to build the documentation. Does drift algorithm makes any assumption in selecting features? No, actually it's not making any assumption, but to be more to be precise about this question, when you when you give the drift coefficient, you don't make any assumption regarding the features, and you just need to give a threshold to drop your features. That's the only parameters you have. What are drift features? I've explained it before. Drift feature is a feature that is not stable between your training set and your test set. Can I contribute to the project? Of course you can. You can. So how to do this? It is written in the GitHub. You have to fork the project to develop some features, and then you can do a pull request on the GitHub. How much flexibility is allowed to customize intermediate hidden steps? How much flexibility is allowed to customize? I don't know what it means. Actually, you can. I don't know if it will answer your question, but you can. So you can read your files. That is easy. You don't need to customize it. Okay. Where you can customize is the optimization process, where you can try different models, different parameters, different encoding for your feature, and so on. So it's very flexible. Yeah. Will MLBox always generate same output for one training set? Yes. So if I understand it correctly, MLBox you can set a random state for your models, and in this case it will output the same output for one training set. So that's okay. There is an example of stacking using MLBox on your GitHub. No, there is not, but I can show you. Actually, there is documentation for this. So it's the same. You have to give the stacking parameters, and you can stack your models. But there is no notebook for this. since it's a bit complicated. But if you want to learn more about this, we can keep in touch, and I will show you how to do this. What kind of feature engineering steps MLBox use to create new features? Can you explain more? Okay, so feature engineering is actually, this is just for the entity embedding, because it is encoding, but also feature engineering step. So it's it's quite the same here. But there is no actually feature engineering like creating, testing a lot of feature engineering, because it's tricky to automate. But it is possible, but it's tricky. This package might be good for competition, but how do you fine-tune business use case, like, for example, reducing false negative using ROC curve? Okay, so yeah, of course, this package is good for competition. I've tried it on several Kaggle competition using stacking and so on. But regarding the business use cases, actually, you can try different metrics. So if it's only about reducing false negatives, you can enter your metric and you will optimize regarding your false negatives and so on. So you can do this, and you can only output a feature importance. But that's what you can do. How accurate is it in more complex data sets? I think to answer this question, I invite you to test on Kaggle competition, or on other Kaggle competition, and you will see how it performs on complex data set. But it can't deal with, for instance, images. So in Kaggle, you have a lot of competition with images, and you can't run MLBox on images at the moment. But it's in my roadmap, but at the moment it's not possible. But for heavy dataset, it works. Actually, it works. Does this package has any support for NLP? No, at the moment it's not. MLBox doesn't deal with text features, but it's also in my roadmap. The idea is to deal with text features, images, and so on. So it will come soon. Regarding the drift detection, which method is implemented on MLBox? Drift detection is using a classifier, as I told before. But the classifier, it's a decision tree. When MLBox going on Anaconda, it won't go on Anaconda, unfortunately, because as I told before, XGBoost and LightGBM are not available on Anaconda, so it's not going to be on Anaconda. But it is on the Python package index, the official repository for Python packages, so you can download it from the PyP, and it is available on Kaggle kernel. So you can, for those who don't want to install MLBox, you can fork the Kaggle kernel and run MLBox without installing it on your laptop. So is it the drift only based on the ROC coefficient? Yes, only based on the ROC coefficient, and of course you can try different measures. Here the idea is that if you have a training set that is bigger than the test set, the ROC I say is more accurate than the accuracy coefficient or other metrics. But you can try other metrics, of course. Is feature selection done by using random forest? No, it's not. I've tried using random forest classifier, but actually I don't understand the question. No, feature selection, yeah, is done by using random forest, but also you can choose a regularization, and you can select also with the variance criteria. That's the only possibilities you have. But of course, I will add some other feature selection method in the MLBox. When MLBox going to I can have answered. I understand that drift depends on how many unique level we have in categorical variable like name. Is it correct? Of course, it is correlated, but you can have you know features that is that does not contain a lot of level. It can be also drifting features. So yeah, it's not correlated actually. It's not. It's correlated, but it's not always the case. Yeah. Does MLBox work on unstructured datasets? It's a good question. Actually, it's a difficult task to automate. Unstructured datasets is at the moment it works only on CSV file, JSON file, and other format, but it doesn't work on graphs or. Yeah. It has to be done, you know, case by case. How can I create a pipeline of multiple algorithms using bots so I can fine-tune the best model? You can set, actually, there is a parameter that is called strategy, and you can try different strategy for your model. So you can try a tree, you can try a random forest, okay? Then you will tune the best parameter for your tree, the best parameter for your random forest, and you will then choose whether you fit with a tree or a random forest or whatever. How complex is it to use MLBox in more complex datasets? Actually, what is a complex dataset? If it's only about a size, it's not a problem. You can run MLBox on heavy datasets, it will work, but you will only need to have dataset with numerical feature, categorical features, dates, it will encode it for you, list, and the text, it will work, but it will not encode it with a smart method, but it will work. Thank you for the stack. So for the stacking, we have to train all models before our MLBox is generating several models. You will have to specify the models you want to have in your layers. So there is the documentation I can show you for the stacking, the stacking classifier or regressor. So documentation. Here is the official documentation. So if you have a question, you can always refer to this page. It's easy. Here is the models you can try. So, sorry. It's not here. Model. Okay, here's the model. For classification, for instance, you can have stacking classifier. Here is the stacking classifier. It's quite complicated, but the first parameter is base estimator. So it's a list. It's very important. And default configuration is XGBoost, random forest, and extra trees. Here is the first layer for your stacking classifier, and the level estimator is a linear model. But in the MLBox, where is the here for the MLBox? Here, if you want to try stacking, you have to write stacking and your parameter and your configuration here. Like for this, so you will write stack underscore and base estimators, third choice, and the list of the models you want to stack. Okay. So there exists a default configuration for stacking, but you can also stack all the models you want, and you can have like 5 layers or whatever. You can do what you want. Can it handle text classification problems? Actually, it will work, but it's not very clever on text. It's not dealing with text. So it will deal text features like categorical features. So it's It's not working actually. Is there a way to do dimensional reduction with this package? Yes, you can do feature selection. That's all you can do. You can't do a PCA at the moment or other dimensional reduction techniques, but you can reduce and select your features. It's possible to use MLBox on very imbalanced data sets. You can have a try, I don't know, but it's possible. You can tell me if it works. I don't know, but it works on a multi-class problem. So, do we have to retrain the model if new data is coming in training dataset, or is it automated? It's a very good question. This one, I have tried to handle this case, but it's very complicated actually. At the moment, what you can do with the MLBox is that you can have several files with duplicates. So for instance, you have one database, let's say in 1 year ago, and this year you have another database that is updated. And you don't know where are the duplicates, but you can input to the MLBox both datasets, and it will automatically understand that there is duplicates. Okay, but you have to retrain the model on the old training set. It's not online. Actually, it's not online learning. It's a classical machine learning model. Have you tested ML performance on time series data? No, I've not tested it on the Kaggle, on the Wikipedia Kaggle, but no. But this is also in my roadmap, to deal with this kind of features, with a time series, with images, text. This will be done, of course, very soon. But it's an important work, but it's in my roadmap. At the moment, it will deal with dates features, but it's not very good on time series data. You can have a try actually, but I think it's not very appropriate for time series. How model selection is done in MLBox? Yes, so MLBox, model selection. You have to set the models you want to try. So it's not fully automated. You have a default configuration, but that is XGBoost or LightGBM, but you will need to enter the model you want to try. So it's called strategy. I can show you here. Here is the estimator strategy choice. Here is only LightGBM I want to try, but I can write here XGBoost and random forest and so on. And then it will optimize a different strategy. Okay. Okay, please. Please share the link of MLBox official page. Of course, I can do this. Here is the GitHub, and here's the official doc. You can find it on the GitHub. It's okay. Well, if you have any question, feel free to ask. Otherwise, it's okay.
Thanks, Axel.
Yeah.
Thanks for conducting such an interesting webinar.
Yeah. Thank you to all the participants.
Thanks everyone for joining us. We appreciate you being here. Thanks again, and till the next time we see you.
Thank you very much.
Good night.
Good night. Thank you very much, guys.